Hello dear colleagues. Group of researchers of the Technological Faculty of Batumi State University, Shota Rustaveli, Georgia, Maya Tohushi, Boris Karasiev, Gizo Patschaladze, Madonna Loria, and Kocha Chavleishvili are very happy to participate in the conference and share the results of our research. Topic of experiment: increasing the accuracy of measuring the resistance of the ground system with an electrodeless method. Recently, electrodeless methods of measuring the resistance of grounding devices have appeared, with the help of special clamps, but a large methodological error limits the possibility of their use, especially when rationing low resistances. The article shows the possibility to improve the accuracy of electrodeless measurement methods using commercially available measuring instruments. In electrical installations of telecommunication networks of building structures and industrial enterprises, the form of the AC voltage signal of the industrial supply network can differ greatly from the sinusoidal for short periods of time. The causes of distortions are usually associated with a sudden change in network load. For example, when you turn on a powerful electric motor, furnace, welding machine, etc. The occurrence of impulse over voltages and interference caused by electromagnetic effects, lighting, switching, radio frequency, and others, on low voltage networks not only leads to failure of electrical installation, cables, switchboards, but also to damage the terminal equipment and malfunction. This is due primarily to the saturation of modern buildings and structures with information, telecommunications, and other digital equipment, which has a very low level of protection against impulse over voltages and interference. All this makes it necessary to carry out appropriate protective measures. To reduce interference, it is necessary to perform a separate working ground loop, the resistance of which must be measured and periodically monitored. There are devices that allow an electrodeless method to monitor and evaluate the resistance of the ground loop, but these devices have a greater measurement error than devices that measure the resistance of the earth electrode method. The article deals with existing instruments CA6410, MZC303E, which can evaluate the resistance of the earth electrode and the possibility of increasing the accuracy of the measurement with the help of special current clamps which are shown. Using a predetermined value of neutral independence, the measurement error of the calculate resistance of the earthing switch can be determined with a great accuracy. Here are examples of measuring the resistance of the grounding. Measurement in a standard way with a resolution of 0.001 ohm, and lower measurement of grounding of high voltage line supports without disconnecting them. For these purposes, the world market offers a large selection of devices that guarantee the necessary accuracy of measurements, provided that the user meets certain operating conditions. Unfortunately, these conditions are not always feasible. In particular, instruments of measuring the resistance of the grounding device, in addition to the performance of the climatic conditions of operation, require the specific placement of current and potential electrodes, metal pins jammed into the ground, relative to the investigated ground contour, depending on the geometric dimensions of the circuit, and set the maximum permissible earth resistance of the electrodes themselves, depending on the resistivity of the soil in which they are placed. In the central part of any city, where the saturation of buildings and underground utilities is high, solid asphalt or concrete, the application of these devices becomes impossible. In such cases, reckoning methods are used to determine the resistance of the GD. Given the known geometric dimensions of the ground contour, under investigation in the known resistivity of the ground, these initial parameters are practically unknown, and therefore other methods and means of measuring the resistance of the memory are needed, independent of geometric dimensions of the grounding loop and the resistivity of the ground, electrodeless unpin methods. This method excludes the placement of auxiliary electrodes in the ground, greatly shortens the measurement time, and is often the only possible one. Electrodeless unpin methods consist in measuring the resistance of a closed electrical circuit, which must necessarily include the measured grounding electrode. This method is realized by means of two current clamps or by current mites, in which two transformers are combined, one of which creates an EMF in a closed loop and the other measures the current in the circuit. Devices for measuring the resistance of the earth electrode by electrodeless unpin method in their documents guarantee the obtaining of the necessary results, even when measuring small resistances. For example, the manufacturer of the device CA6410 guarantees the accuracy of measuring the resistance of the earth electrode of about 1.5%. See figure. To create a closed electrical circuit the developers propose to use the neutral wire and neutral ground of the supply transformer. It is assumed to use a powerful supply system with a dead grounded neutral, in which the resistance of the neutral wire and the ground contour of the transformer neutral can be neglected. When the test voltage E by means of a special transformer is applied to the grounding rod conductor, which resistance Rx, the resultant current I begin to flow through the circuit. The resulting current I is increased by the receiving coil. The internal filter of the instrument, tuned to the frequency of the applied test voltage, cuts off all currents except the resultant current I, which is equal to I equals E divided by R contour. Knowing the value of E, which is given by the generator, and I, which is measured, we can calculate the R circuit. This value is displayed on the screen. This approximation is only permissible when measuring the resistance of the earthing switch above 10 ohm or more. In the figure is shown a device MCC303E that calculates the expected short circuit current based on the impedance of the short circuit contour. The device is recommended for measurements in electrical installations, networks of buildings, structures and industrial enterprises in which the error caused by neglect of reactive resistance can be of significance. Based on the meter reading and measuring the expected short circuit current, it is possible to select the required values of residual current circuit breakers for each power supply circuit. The device allows to monitor the integrity of the zero protective conductors to carry out measurements without disconnecting the power supplies and protection and to evaluate the resistance of the grounding device. When assessing the resistance of the grounding device to the measurement result, instead of the resistance of the neutral wire, the resistance of the investigated circuit in the grounding contour of the substation feeder transformer will be included. To increase the accuracy of measuring the resistance of the grounding contour in an electrodeless unpenned manner in the first and second cases, it is necessary to reduce the total resistance of the grounding contours in the neutral circuit of the substation transformer. For example, performing neutral ground loop of a substation transformer with a resistance of less than 0.5 ohms. True, this is a very time-consuming and expensive option. There is an option and a simpler way, which consists in determining the resistance of all external ground loops connected to the neutral of the transformer. If you know the intrinsic resistance of the earthing contour of the substation transformer when it is put into the operation, then calculate the total earth resistance of the neutral and introduce it as an amendment to the result of the measurement of the ground loop being examined. To implement such an option, it is proposed to measure directly on the substation the resistance of the closed electrical circuit formed between the internal ground of the substation transformer and all external earthing switches. For example, using test clamps, considering the connection of all external circuits by zero wire, the calculated value of the total resistance of the neutral for each transformer should be known and periodically fixed in the transformer's passport. This is examined by the figure 3, where it is indicated L1, L2, and L3, winding of the transformer feeder of the substation with a deadly grounded neutral, ZT, known internal resistance of the earthing substation of the substation, ZS, resistance of the ground loops of electrical consumers connected by a neutral wire to the neutral of the supply transformer. Considering that ZT is known, it is indicated in the passport when commissioning the substation. We can get the calculated value of the total resistance of the auxiliary grounding and included in the neutral ZS divided by 3 equals ZX minus ZT. The total resistance of the neutral ZR is given by formula. And in the future, to enter this calculated resistance value into the result of measuring the resistance of the ground loop under study as an amendment. As a result of the generalization of the above and similar electrodeless methods for measuring the resistance of earthing devices, we arrive at the following conclusions. For example, by including a new consumer equipment in the system that requires grounding of the neutral and observing the small values of the earthing resistance in the figure, knowing the value of the neutral resistance ZR and measuring the resistance using the current clamp ZX, it is possible to determine the resistance of the equipment ZG with high accuracy. As a result of generalization of the above and similar electrodeless methods of measuring the resistance of earthing switches, we arrive at the following conclusions. The use of electrodeless unpin methods is justified for rough estimates and when the measurement results are less than or equal to expected necessary values. It means that the results will always be greater than the actual values. The large methodological error of electrodeless methods does not allow using the obtained measurement results for official presentation and recording of these results in the documentation. With the help of predetermined value of the neutral resistance, the error in measuring the design resistance of the earthing or grounding device can be determined with great accuracy. Here is a list of the references we used. Thank you for your attention.